Did you watch The Walking Dead? Oh, I love that show.
Okay, so chapter 13. Chapter 13, as it says.
We didn't do our Monday checkup.
No, we didn't. It's on.
That's not like this one.
All right, so we're going to start out by exploring periodic data. And periodic function, quite simply, they have some examples if you're on page 820 of things that happen periodically. The first example shows the sun and our planet Earth. Okay? And the reason why that is a periodic function is because the Earth rotates around the sun periodically, and it's a set, repeated amount of time that it takes to go around the sun.
Before you get to the picture, what are those signs?
Love dip. I don't know what that is. Okay, heartbeat. A heartbeat is another example of a periodic function because as it goes, it beats at regular intervals and usually with a regular strength. The little girl on the swing is a periodic function. So she goes forwards, and then backwards, and then forwards, and then backwards, and then forwards and backwards, and so forth. And waves are another one because they go up on the beach and then recede, and then up on the beach and then back down, and things like that. Okay? And so what they want you to know is that a periodic function, the definition of that, is a function that repeats a pattern of y values at regular intervals. Okay? So to go back to the examples that we just talked about and try and connect that with this definition. In the sun example, our distance from the sun might be the y value that they're talking about, and our distance from the sun is repeated at a regular interval, right? We are the same distance from the sun every year at the same time of year. In the heartbeat thing, the y value might be the the expansion or whatever of the heart. In the swing, her distance forward or backward might be the y value, and again, those are repeated at regular intervals. And same thing with the waves. The distance that they are up the shore is repeated at a regular amount of time. Okay? So we got some other fun words here. One complete pattern is called a cycle. Okay? So, for example, what is the cycle of this Earth going around the sun?
A year.
365 days is one trip around. One cycle is all the way around. And the amount of time that takes is called the period. Okay, so the period of a function is the length of one cycle. So 365 days is how long it takes the Earth to complete one cycle around the sun. So that period is 365. For a heartbeat, you'd have to know the interval in between successive heartbeats. That would be the period of that function, and so forth. Okay? Does that make sense? All right, so let's look at some graphs, some examples.
I don't understand what this is going to end up line with.
So let's take a look at some graphs. So like Katie said, we can relate these x and y values things to what we're talking about when things happen regularly. So I don't know what this is supposedly a graph of, okay? But you can tell that it is periodic because why? Because it's repeating in a pattern. Yeah, it goes up, down, up, down, up, down, up, down. And it's going up and down the exact same amount every single time, okay? So one cycle of this function is you can pick any point that you want on the graph. So like this point right here. And then if you go until you get up to that y value again, that is one cycle of the function. So from here to here is one cycle. Okay? Also from down here to down here is one cycle. Or you could be weird and pick a point halfway up the graph and go, but now you have to be careful with that, because if I pick this point right here, then I would have to go up, then down, then back up again to get to the corresponding point on this. And the cycle is the same no matter which points you choose on that graph. And so that kind of is the definition of the periodic function, is that it's repeating in a pattern, which means that any cycle that you look at is going to have the same period, okay? So in this case, the period of this function is 4, because if I go from this high point here to that high point there, it is 1, 2, 3, 4 things across, okay? So let's look at another one. And this one back here, I said that the period is 4, because if I go from this high point to the next high point, it is 1, 2, 3, 4 in between those two high points. Okay? Or 1, 2, 3, 4 in between those low points. Okay?
If you went online and watched this video, could you see all this?
What?
Like if we went and watched this on YouTube, could you see?
Yeah, everything that shows up on the screen shows up in the video. Okay? All right, so let's take a look at this one right here and figure out what the period of this function is. And these are all in your book if you want to get a better view on page 821. Okay? So this is periodic again because it's going up and down and up and down and up and down, and it's doing it in a regular interval. So if you can see up here, or you can see in your book, what's the period of this function? You're going with 4, because if I take this high point right here, and then I have to count over 1, 2, 3, 4 to get to the next high point. Okay? You could do the bottom ones, and you'd get the same answer. 1, 2, 3, 4 over to that bottom one. What's that? We'll do that in just a second. Okay? All right, how about how about this one right here? What's the period of this one? 3, good, because if I go from this high point to that high point, I have to go 1, 2, 3 to get to them, or you can do the low points if you want. Okay? So Katie says, because she's always thinking ahead, what if it's not periodic? Okay? And so this example right here is one that is not periodic. And you have to be careful with this, because it looks like it repeats in a pattern, right? But since the y values are changing, it's going down and then up and then down and then up, but it's not coming up as much each time. So this is not actually a periodic function, because it's, yeah, you sit there and talk to Elliot, and you think I'm going to repeat myself? I tell you to shush, and then you, I don't even. If there weren't people in other countries and other states watching, things could get ugly right now. Okay? So this is not a periodic function, so we can't do that. Okay?
You just don't do anything?
What? So you put not periodic.
Because it's going down.
Okay? Right, because as it's going through its cycles, it's going down at the same time. Right, so no solution, not periodic, can't answer it, whatever you want to say. Okay, this one, however, is good, right? Because it goes up and then down and then up a little bit and tweaks out a little bit, but it does the exact same thing over here on the other side. So those things are the same. What's that? Right, and they match up across here. So if I pick this point right here, how many steps do I have to take to get over to there? 10, okay? And I could do the same thing with this point here. It would take me 2, 4, 6, 8, 10 to get to there. Or I could do the bottom 1, 2, 4, 6, 8, 10 to get to there. So, right, so since the periods are the same, that means it's periodic and it has a period of 10, which is what they're going through with you right here. Okay? All right, so let's see if you know what you're talking about. Is that one on the left periodic? No, it is a repeating function, but it's increasing as it's repeating, so the answer is not periodic. Okay, this one is yes. Okay, what is its period? 1, 2, 3, 4, it looks like, or 1, 2, 3, 4, no matter how you do it. Okay? What's that? A is nothing. Okay. All right, and then we got a little word problem here. It says, if the period is 4 seconds, how many cycles does it have in 1 minute? Yeah, so if we take a look at that and say we have a function whose period is 4 seconds, and we want to know how many in 1 minute.
15 cycles.
Right, since there's 60 seconds in a minute, if you go 60 divided by 4, you would get 15 cycles in every minute. Okay? Let's see what else they got. What is the period of a function that has 180 cycles per minute? So now we're going to go the other way. Now we're going to say in 1 minute, it repeats itself 180 times. So you're asked to figure out how long does it take to repeat itself once. Yes? You went with 3 because you went 180 divided by 60, but does that work? No, because if it went every 3 seconds, then it would only go 20 times in a minute. So your impulse is correct to divide these, but you have to divide it the other way. So you have to go the 60 seconds divided by the 180 cycles. Okay? And that will tell you that your period would be 1/3 of a second. Okay? Or 0.3 repeating, yeah. As long as you say repeating, we're good. Then we can be friends again. You didn't say repeating? Okay, we're still fighting.
Wait.
Not waiting.
Please.
Okay. How about if you've got 440 cycles per second?
That's a lot.
That's a lot.
So we have to figure out per minute?
So if you have 440 cycles per second, how long does it take each cycle to go? Well, that would be 1/440th of a second, right?
That one was easy.
So you just take the time divided by the number of cycles. Does that make sense? So here it was 60 seconds divided by 180 cycles. Here we went the other way around.
So it's just 1/140.
So that would just be 1/440. Yeah, so that would be very short, very quick function. Okay? All right, so everybody good with, everybody good with the concept of the cycle?
Yes. Time copies.
Okay. All right, now there's another thing you have to learn from here. The cycle of a function relates to how long it takes to repeat itself, so that's basically an x value, right? There's another characteristic of functions which is called the amplitude. And the amplitude is how you measure the top to the bottom, okay? And so the way that you do that, if you want to know the amplitude of a function, it is half the distance between the highest point and the lowest point. And so that's right here if you want to write that down in, whoa. You see that? I just like,
What'd you do?
I don't know what happened, but it said print. Okay, we're good. Nope, cancel that. I don't know how that happened. If you want to write this down in your notes, amplitude equals 1/2 the maximum value minus the minimum value. So in this example right here, the highest value is 3, right? You did diligently copying things down in your notes. Okay, so the high point right here is 3, right? And so the high point, the maximum is 3. The minimum is what? -1. So I have to go 3 minus -1, not 3 plus -1. So 3 minus -1 is 4, which all we're saying there is that the distance from the top to the bottom is 4, okay? And then I have to divide that in half. So half of 4 would give me an amplitude of 2, okay? All right, what about this guy right here? What is the amplitude of this? The high point is 4. We're going by 2s now, so be careful. The low point is -2. So I'm going to go 4 minus -2, so that means it changes a total distance of 6. So half of that is going to give me an amplitude of 3. Okay? Awesome question. Can you have a negative amplitude? No, because an amplitude is a distance. Okay? and distance is never negative. All right, so let's take a look at these last two examples, and then I'll turn you loose. What's the amplitude of this guy right here?
1.5.
1.5, good, because 1 minus negative 2 is 3, and half of 3 is 1.5. What's the amplitude of this? What?
Nice.
What's the amplitude of this? What's the high point right here?
3.5.
3. The low point is 0, so this one's also going to be 1.5. Okay?
Just do it.
Yep, so both of those came out to be
Oh, okay.
1.5.
You got me those things like 4 times.
I don't know.
I'm not excited for this. It's not what the yeah, good assignment.
Yeah, that's a lot.
All it is that 6 or 16.
That's 6.
That's a 6.
Jeez.
Thanks, Mr. Alder.
You're good.
You're welcome.
Hey, Elliot. What's up? Hey, what are we doing? Did we just do the ladder?
We're 6 through 2. Yeah. Okay, we're done.
Okay, now on 6 through
Where's the quitter?
19.
6 through 8, the first 3, it says identify one cycle in 2 different ways. So they want you to say like from the high point to the low point or da da da. Don't worry about that. Just figure out the period of the function. Okay.
Right.
All right.